Hi, good evening, everyone. I hope you were able to find the mail. So, thank you very much for joining. Uh, let's start the session. So, before starting the session, since I know that this is the final week, so any concern if you have now, we could sort them out one by one, and after that we could jump into the some modeling and simulation of the FEM analysis. Okay.
Yes, sir.
So, okay, Rajni. So you are able to speak today.
Yes, sir. Yeah.
That's great.
I'm in office now, so I can.
Oh,
Yeah.
you are in office.
Yeah.
Okay.
Uh, Sir, actually, I have a question. Assignment two, sir,
Assignment two.
and question
First
number
share
two.
my. Okay. Let me first share my screen.
Yes.
Okay.
Yes, sir. Yeah.
Yeah. Let me go to the course. Week two. Question number two.
Week two, assignment two.
Yeah. Which
In that
question?
one, second question, sir.
Second question.
Yes.
Uh, let stacking factor. Then the diameter of diamond circle. Okay, so this answer is wrong or method
Oh,
is
no, no,
wrong?
no, no. Answer is not wrong, actually. Answer is correct. Just I want to know procedure. A little confusion is there.
Okay, okay.
Yeah.
Sure, sure. No issue. This type of question I think we had discussed earlier, but we can discuss it again. No issue.
Yes.
Let me present my iPad screen so that Okay, so the question is, if the net iron area of the core is, question number two, week two, question number two. So net iron area is 270 centimeter square. Okay.
Yes, sir.
A stacking factor is
Point 0.9.
0.9. Then we need to find out the diameter of circumscribing circle. Okay. Now, let's suppose we have a transformer core like this, like this. Okay. So what should be the circumscribing area? What will be circumscribing area? Which will be covering this core,
Yes.
isn't
Circle.
it? Okay. So now we need to find out the area, yeah, diameter of circumscribing area. So if we could find out somehow area of that this cruciform core or this circle, then then I think we can find out the diameter, isn't it?
Diameter. Yes, sir.
Yeah. So this net iron core area is given 270 centimeters square. So can we somehow find out the uh, this length, window length or something? Can we find out? So
Area they given us. So length we
yeah,
can
area is given. So first we have to
L.
utilize our stacking factor so that we
Okay.
could get a total area. Right?
Yeah.
Yeah. So after that, what we could do, we have to find out the relationship between this area of core and area of the circle, isn't it?
Okay.
Yeah. So what will be area of core itself is given. So first find the total area of the core, and then
Mm.
how can we relate with the area of this core and area of the circle?
Circle.
Yes.
So area of the uh, iron core
Yes, area of the iron core is given, right?
to yes, sir.
Huh.
So this area in the sense grasses.
No,
Ye-
this area I told now, always whenever area is mentioned in the problem, what to consider? Cross section. And what I mean by cross section is, sorry, yeah, what I mean by cross section is this section,
Yes.
this section.
Mm.
And one more trick I told, whenever you are asked to calculate area in any magnetic circuit, first identify what will be the path of the flux. Okay, so path
Mm.
of the flux will be like that, like that.
Yes.
Okay.
Yes, sir.
Now leave that dimension and accept that dimension, whatever dimension remains, that will be your area. Okay.
Okay.
So here the area will be this is the path of the flux, right? So now this length you have to multiply with the axial length. So that will be cross sectional area. You got it?
Okay. Yes, sir.
Area will be, let us suppose this is the width of the core. Okay, not window, width of the core, and axial length is L, which is into the page. So that will be total area.
Okay. Can we solve, sir? Ah,
Yes, sure. So you tell me what should be our approach here. So first thing
first we have
we
to
have
uh,
calculate the gross area of the iron, right?
yes, first gross area and after that area of the core
Yeah, gross area, how will we
circle.
calculate?
Circle.
270 centimeters square.
By
Divide or multiply. A stacking factor?
they given divided by 6.
Multiply.
Yeah, divide.
0.9.
Yeah, Chitu, you are saying something?
Sir, actually, the formula is net area by gross area will be the stacking factor, no, sir.
Exactly. No, no, net, yes, yes, you're correct. Net area by gross area. So whichever quantity is lower, that will be in the numerator, right? So gross area will be
Yes, sir.
always higher than the net area. Why? Because of the inclusiveness of insulation. So this will come out to
Uh,
be,
the area of the circumscribing circle.
sorry, I couldn't get you. Please
So
repeat.
here
Huh.
the gross area will be the area of the circumscribing circle, no, sir.
The area of the circumscribing circle. Right, right. Yes.
In the question they have given like the gross iron area will be equal to zero point
Area.
0.8 times area
Uh-huh.
of
Area of
circumscribing area.
circle circle.
Exactly. So here they are mentioning this information directly,
Okay.
right? So
Gross
rather
area.
than calculating like this, you could directly, equate also because this information they have given directly that gross iron area is equal to zero point 0.8 times of area of the circumscribing circle. So what we do not need to calculate the area of this circle, right? Because they are given directly.
Direct zero
Otherwise,
point 0.8
uh,
times they
yeah.
given.
Otherwise, what I thought how to calculate this is to calculate this length first and then multiply with root 2 and you will get this diameter. But now since they are providing it directly and once we got this diagonal length, then we know that this is the diameter of the circumscribing circle, right? And from there we could calculate. But since they are mentioning here directly that in the bracket section, that information I did not see. So that here, this
300.
gross area of iron will be equal to zero point 0.8 times 0.8 times area of circumscribing circle.
Circumscribe.
Okay. So this 270 divided by zero point 0.9 will be how much?
300.
Exactly 300. Yes.
300, sir.
300 centimeters square we have calculated for the iron area, and
Yes.
that is equal to zero point 0.8 times of area of circumscribing circle. Now, the next step should be we could get directly the value of area of circumscribing circle. That will be 300 divided by zero point 0.8.
0.8.
So it will be higher than 300, and that is expected also, right? Because it is circumscribing the cone. So it will be 375 centimeter square.
375. Yes.
Okay.
Mm.
Now we have got the area. Now other way around the question is asked the diameter of circumscribing circle we have to calculate. So it will be what?
Pi d
Pi
square.
pi r square or pi d square by 4. Right?
4
R is
equal
equal
to
to
3.
d by 2 if you plug in.
Yes, sir.
Right. So here d will be under root 4 into 375 by pi, isn't it?
Yes.
Yeah. Now we could calculate it. 4 into 375 by pi. It is coming out to be
21.85.
21.85
Yes, sir. Correct.
centimeter. Yes.
Yes, sir.
Okay.
Yes,
You
sir.
got it. I, yeah, I think we had discussed. So you had solved this problem during the assignment, right, Rajni?
Yes, sir.
Okay. You just forgot the concept. That's why you are.
Sorry, sir. There is one more question also. I'm having question number 7. Only
No
this is 7.
problem. Yeah, yeah, sure, definitely.
No, that is the last.
So, uh, seven number, right? Seven
Yeah.
number is A single phase.
This is from
Uh,
which
This is
week?
from
Assignment
week
2.
week two.
Assignment two.
Yes.
Okay. Okay. Thank you.
Single phase.
So
God.
single phase.
No, 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 sir. It's the temperature rise of a transformer is 25 degrees centigrade after 1 hour.
Acha, that question number 8 you are saying.
It's a 7. Number 7.
Is it?
Question number 7. The temperature rise of it
In my
in
It is
our.
eight.
It
It
is
is eight. Eight.
eight.
Eight. Yeah. Hmm.
Then why they given 7 in assignment?
no problem. The question is related to temperature rise only, right?
Yes, the
Yeah.
temperature rise of a transformer.
So we will go ahead with that. Right.
Assignment two. Question number eight. Hmm.
Yes.
Oh,
So
yes, it's
temperature rise is
6.
uh, 25 degrees centigrade after 1 hour and 37.5 degree after 2 hours. Starting from the cold condition. Calculate the heating time constant. Okay. So heating time constant we have to calculate. Right. So what will be here heating time constant? That is you have to relate in terms of electrical condition, right? How in the electrical condition it happens. In electrical condition, the more transient it will have, like there is a transient equation of Charles, right? If you have applied a potential across the capacitor, how this VC will increase. If you have studied the transient, that will be like 1 minus e raised to power minus t by tau, where tau is equal to
I see.
RC. Okay.
That's
So if R is not there, then it will charge immediately, right? So if R is not there, which means R is equal to 0. So time constant is 0. What does it imply? Time constant is 0 means it will immediately reach the steady state. There will not be any transient.
Hmm.
Okay.
Yes.
Similarly, here, in terms of, always try to relate thermal thing from the electrical equivalent. Okay. So this theta temperature, how will it reach its its maximum temperature? Theta is equal to theta maximum 1 minus e raised to power minus t by tau. This tau we have been asked to calculate. Okay. So we are given with two conditions. Similarly, like we are generally provided with RC circuit. Like after this time, we have reached up to this potential. After some certain time, we have reached certain potential. So similarly, like here, this temperature is after 1 hour. Okay, after 1 hour, it is 25 degrees centigrade. Okay, theta maximum we do not know. Let it be 1 minus e raised to power minus t. So t here is 1 hour.
one.
1 hour divided by time constant. So as of now, please remember that this time we are carrying in terms of hour. We again have to change. We might have to change it. Now after 2 hours, 37.5 degrees. Why I said ki we might need to change it, because if we are taking the ratio, then there is no need to change. Otherwise, if you are doing some equation based analysis, then you have to properly write in terms of units. Now again, theta maximum will be set because that is the steady state temperature. When we do thermal analysis, also we know some steady state temperature, right? 1 minus e raised to power minus 2 by tau. Okay. So now can we have, this is equation 1, this is equation 2. Can we divide it? Equation 1 by equation 2. We will have only one unknown, right? And that will be time constant. So if we divide it, so we will have 25 divided by 37.5 equal to theta m 1 minus e raised to power minus 1 by tau divided by theta m 1 minus 1 2 by tau. Okay, this theta m will be cancelled out. 25, I am bringing this to here and I am bringing this to here. 1 minus e raised to power minus 2 by tau is equal to 37.5. 1 minus e raised to power minus 1 by 2. Okay, so this 25 e raised to power minus 2 by tau. This is minus plus 37.5 e raised to power minus 1 by tau is equal to 37.5 minus 25. Okay, so this is the final equation.
Yes, sir.
So 37.5 e raised to power minus 1 by tau is minus 25 e raised to power minus 2 by tau is equal to 12.5. So we have e raised to power something in the equation. So which function we have to apply here? Logarithmic function, right? So we have to apply ln on both the sides, right? That's ln. Okay.
Okay.
Now we can calculate ln here. In your calculator also this ln function is there, right? So ln of logarithmic of two product is equal to logarithmic of sum of two products, right? So it will be broken into ln of 37.5 plus ln into e raised to power minus 1 by tau. Similarly, for the second product, it is minus. So minus ln of 25 minus ln of e raised to power minus 2 by tau. So far, so good. Any doubt till this point?
No, sir.
Okay. Now, this ln of 37.5 and first thing first, this ln into e will be cancelled out. So it will remain only minus 1 by tau.
Okay.
Okay. And the second product minus minus, sorry, this is minus and ln into e will be cancelled out. So again, minus 2 by tau will only remain, right? And on the right hand side, we will take all the constants plus ln 25 plus, sorry, minus ln 37.5, right? Now we have this 2 by tau minus 1 by tau, right? So it will be 1 by tau only, isn't it?
Yes, sir. 1 by tau.
1 by tau. Now ln 12.5 plus ln 25 minus ln 37.5. So that either you could calculate on your calculator also, or you could apply, multiplication factor ln into 12.5 into
Okay, total
25 into
30.
like that. Yes. So let me solve it. Minus ln 37.5. So it is coming out to be 2.12. I hope you might be also getting the same 2.12.
2.12.
Yeah. You are also getting the same?
Yeah, 1 second, sir. I'm getting something different.
Okay, okay, no
2.5.
problem.
Okay, sir. Fine.
You are also getting
Yeah,
same, right?
getting same. Yes, sir. Same, same.
So tau will be 1 by 2.12. So it will come, whatever this value will come out, that will be in hours. Why?
0.471.
Yeah. Why? Because in the numerator also we have taken the value in terms of hours only. So it is 0.71. 1 divided by
0.47.
0.47.
0.471.
0.47 hours. So that is the time constant of this.
Sir, here they given different, sir.
How much answer they? Oh,
1.44 hours, sir.
1.44 hour. Have we done some calculation mistake? Let me verify it here. 25, 37.5 is going to take.
35,
Yes.
37.5, correct.
So anyone else has got the correct answer and has they submitted already? Because I have verified my calculation and I don't see anything wrong in it.
Yes, sir. I have the correct answer. Just I'm checking my lecture notes. 1 minute.
Yeah, please, yes.
Right now, I'm not able to find out that pages. Oh, sir,
Okay.
just
Means you were able to get the correct solution. So it means
yes,
there might be
yes,
some
yes.
mistakes in my calculation. Okay. So because they have also provided and you have also got, so there is high probability that some calculation mistake I have done. Mhm.
Okay, sir. The procedure is we know now. We'll try, sir, once
Yeah.
again.
Yeah.
The way of doing is important. No? So that's actually understood, sir, what you told.
Oh, okay.
And in the assignment 2, the question number 9.
Assignment to the question number 9, the field coil one, right?
Yeah.
Okay. So
This formula.
Yes, I think I have put a mistake in a point because I'm getting 182.79 and the answer is 18 point something. So
okay,
somewhere
okay.
maybe.
Yeah.
Rajani madam, are you getting the same answer? Right answer?
Uh,
Ninth.
Actually, they applied in the formula only, na ma'am. Q by S
Hmm.
into lambda. Q is
Hmm.
the that
Hmm.
power splitting.
And
I will
10,
check
11.
once again. 170.
Hmm.
surface 0.25 surface area. Specificity 34. Ma'am, 20 है ना?
The answer is 18 high, 18 to 22.
18 to
Yeah,
22,
so
but we are getting 20.
20 must
Yeah.
it must come. Yeah.
170 by 0.25 surface and surface area. That one is heating dissipating surface and into emissivity coefficient.
Okay.
Yeah. So this temperature is this theta is this
Q by S
power how
lambda.
yes. Similarly, rho by LA something or we know na L by sigma A from the electrical conductivity, right?
Yes, sir. And okay, resistivity also
So the
R equal to L by mu into A.
yes. So similarly here, it is the power how much it is being lost divided by emissivity. Yeah, it is in the unit also. If you just take care of the unit only, then you will be
Yes.
able to get it. Yeah.
Yes.
Units also all they given in SI only, na sir?
Yes, yes. So that's why SI units are there. Power is given. So what by what has to go out, right? Only degree centigrade has to come out, right? So
Yeah,
the
everything is directly they given.
yeah
Sir,
unit is
direct.
like meter square into degree centimeter, right?
Yes, yes, sir.
It is 34. So now
34.
we have to definitely it will come
Hmm.
into the denominator if you take care of unit only. So 1 by 34 meter square into degree centimeter divided by watt. Now it will be multiplied with watt so that this watt will go out. So 170 watt, right? So this watt and watt will go out. Now only thing remains is area, right? This meter square. Meter square is the unit of area. So
Area.
now we have to divide with 0.25. So this meter square will go out and we are left with this power divided by this 34 is the emissivity or
Emissivity,
conductivity if you can say in terms of electrical into 0.25
surface area, dissipating surface area.
exactly.
It's a
So
20.
you are left with 20. So
20.
it will come out exactly equal to 20.
20.
So wherever you are not getting any clue, just focus on the units and such type of
Hmm.
one-liner questions you will get the answer. Okay, any other concern here?
No, sir.
No, sir.
Okay, so everything is fine. Remaining everything is fine. Nothing
Yes, sir.
from other week's content also, right?
No,
Sir, in assignment 3, the last question 11, the number of conductors connected in a series.
assignment 3,
Hmm. Question number 11.
question number 11. పదకొండు okay. Sir, what is the correct answer for that? I given one over there. Like
Oh, it is wrong for you
assignment 3,
also.
yeah. 1 second. Assignment 3, 11. Question number conducted in series.
So it is based on DC machines, right?
Yes, sir.
Yes, sir.
Yeah, let's solve it.
I'm getting 23 answer.
Oh, you are getting
Let
23.
me check.
Oh, half. Let us solve it and let's see. Question 9 to 11. Question number 11. Anyway, EMF, everybody is able to get, right? Correct.
EMF
Correct.
is 8.65. Sorry, 405.
405. Okay, EMF is
405.
1 minute, 1 minute. That is related to the question number. Yes, 8.657.
8.657 is the EMF per conductor. 8.5,
Hmm.
sorry, 8.567.
Yes, sir.
8.567 volt per conductor.
Hmm.
Right. Now, so total number of conductors are,
Total number of conductors is equal
oh,
to,
it is not mentioned, is it?
yes, it is not mentioned.
Okay, so basically we have to calculate total number of conductors that are connected in series. So that is the question number 11 itself. Right. So,
Hmm.
so what is the EMF for entire winding? EMF for entire winding will be Z phi n by 60 into P by A,
Hmm. Yes, sir.
Yes, sir.
where where Z is number of conductors.
Conductors.
Hmm.
Okay, so EMF we have value EMF of
So
in
if we
wind.
take in E by Z, then it is 8.657 E by Z.
Exactly.
Yeah.
E by Z is
8.567.
8.57 is equal to 5 into n by 60. And since it is no information regarding winding type, so P and A will be cancelled out. We will consider lap winding. So in lap winding, A is equal to P. Okay. A is parallel path, P is number of poles.
Hmm.
So in
Poles.
lap winding, parallel path is equal to number of poles. In wave winding, always parallel paths will be equal to number of
Two.
2. Yes.
Hmm.
Phi, are we given phi flux density?
Flux density is not given, but we can find out because I think uh,
BC.
maximum flux density is given, sir.
Flux density is given, then we have to find out the flux, which will be flux density
In
into
area,
area.
I think pi dl. Area.
Pi dl. Yeah, number of poles is not given, so we have to go ahead with pi dl. Okay, so phi will be pi dl by p, generally the area per pole. Flux will be b into b average into area, b into pi dl by p.
Sir, here the P is a pole pair or number of poles in the general case?
Here number of pole.
Number of poles, yeah.
Yes. So b is given as 1.01 Tesla. Pi d is 1.3 meter. L is 0.3 meter. Number pole is not mentioned. Then we have to consider equal to 2. Okay. Because at least one pole pair should present in the machine,
Yes.
right? Yeah. So how much phi you are getting? This flux value is coming out for me 0.619. So total flux generated. Assume form factor. So form factor also we have to multiply. Yeah, because why? This 1.01 Tesla is not average, right? Here we have considered average value, but 1.01 Tesla is the maximum. So form factor, if we multiply with the form factor, then we will be able to get the average value. So the form factor is zero point 0.7. So now 0.6187 into zero point 0.7. So it is coming out to be 0.433.
0.433.
Yes.
Sir, maybe pole pairs, sir, because the answer they given is 0.866 Weber in paper.
Oh, is it? We have area of pole, right? This
Mm-hmm.
area will be area of pole. because whatever the flux is going per pole,
Ideal by P, correct.
if we consider pole pair, no, it should be pole because let's suppose this is the
It must be pi dl by p, sir. Yes.
Uh,
yeah
Ideal
number
by
of
P equal to 1 only, then
yeah then the answer will come, but we do not have to think according to the answer, right? So
Because in the derivation of this equation, the p is equal to number of poles.
Yes,
exactly.
P five
So
zn
poles.
upon 68.
from
Yes,
the
sir.
physical representation also, if you see this flux
Hmm.
linkage also, this is corresponding to this pole, right?
Yes,
How
sir.
much in one pole, that much flux we have to consider. So
Hmm.
so phi should come out to be 0.433. Okay. Because see, if answer is wrong now, it could be corrected later on. But if concept is wrong, then it could not be corrected. So now, yeah, please.
Maximum flux density of core we have to consider or for air gap because
Flux
in
density,
Whom
have
it's
given
correct, sir, my value at the time.
air gap.
flux density for air gap, yes.
So is that okay? We should use air gap's flux density only, yes, sir.
Ah, sorry. Yeah, you are correct. We are calculating here flux in the air gap. Why? Because whatever the flux is there in the air gap, they are only tend to cross and again enter to the cores. So that is why we are concerned with the air gap flux density. So corresponding to the air gap flux density, how much area you are considering to make that flux linkage, right? So in a pole here, this is your air gap, right? So air gap is present around the entire circumference, but flux will be, symmetrical along the pole pairs. In one pole, how the flux will flow. In other pole also, the flux will flow in the similar fashion. Let's suppose this is the core here. So this is the flux like this. So half of them will go to the other pole, right? Sorry.
Hmm?
Sir, actually, that time we did, sir, this one. So at the time we given value is formula is total flux generator equal to form factor into B into pi dl by P by 2. That we use it, sir. I got that answer 0.866 Webers.
Is it? Let me open that
Yes,
notes.
sir. When we discussed na first time, like when
Yes,
assignment is
yes, we
discussed
have
na.
discussed during the
Yes, sir.
assignment period. Okay. So the basics is like this. Half of this pole flux will go in this direction and it will link like this. Okay.
Another one.
And half will go in here and it will link like this. So this is the like this is going in the opposite direction like this. So this air gap flux is corresponding to entire pole, right? Though half are going in the other direction, half are going in the other direction. But this air gap flux is corresponding to the entire pole. Is that what you were asking, Chitu?
Yes, sir.
So is it clear now?
Yes, sir.
Okay. Now coming back
Understood.
to the yeah, thanks. Now coming back to the number of poles and pole pairs, right? This air gap, average air gap flux density value here, this average value is given for this entire area wherever the pole is present. So either you consider this, right? Either you consider one pole, and corresponding to the area you consider, or you consider area of a pole pair and then calculate the flux linkage for that area. Okay, because flux density is gonna be same. Only thing will change is area according to the pole pair. If you consider pole pair, then your area will be doubled because your length will be doubled, isn't it? You're getting my point? Why I am saying so? See, if flux is like this here in one pole, okay, it is symmetric for other pole also. Okay, so flux density around the pole, the flux density B1 is equal to same here, B1. Okay, so flux density is same. The confusion is arising in the flux linkage, which is B into area. And area is what? Pi dl. If you are considering pi dl, it means you are considering for entire rotor, entire number of poles. Okay, you are getting my point?
Yes, sir.
Yes, sir.
Yeah. If you divide it by number of p, then you are getting area for a pole pair corresponding to the pole pair. So whether you consider pole pair or pole doesn't matter. You calculate area accordingly. So how much area will be for one pole and how much it will be half of the pole pair, that is for sure. But how much will be that? That area first we have to calculate area of pole. Area of pole will be
Pi dl by p.
pi dl by p.
P.
P is equal to
P
number of poles. Yeah.
number of poles. If you are considering area of pole pair, then equal to pi dl by
P by 2.
Two.
p by 2.
P by 2. Yes.
P by 2. Right. So we are given all those values, dl divided by p. If you want to
P
consider
two.
p by 2, then
One for the
you
P.
okay. So accordingly, so this here we have calculated divided by 2 here is corresponding to the number of poles. Yeah, so it is the area for, yeah, it is area for a pole, right? It is area for a pole, pi dl by p. P here again number of poles.
Yes.
So this is area for,
Sir, area of the pole P you given area of the pole pair Y 2P by 2. Sir, 2P will come, na? One
area
pole
of
it is P.
mhm,
If it is pole pair means two poles. Then it
two poles.
2P,
No,
no?
madam, it will be reduced. Now, suppose consider that the number of poles are 6.
Mm-hmm.
So pole pairs are 3, na?
Yeah, pole pairs are
Yes.
3 and area
So
will
that is
increase, right? Area has to increase according to the consideration of number of poles.
Area will increase. Yes.
So p by 2 means 2 will go on the numerator. Did you get it point? This point?
Yes, sir.
Yeah. Yeah, I understand your concern. You are more concerned about the answer. I know, but this is how actually we have to think. Maybe I am wrong. If you are getting some other way to convince this logic,
no,
then
sir, the concept is correct. Yes,
Yes.
whatever we are doing, concept is correct. My answer is also the match with the answer, but it should be the, as per the calculation, it should be the 0.433.
yeah,
Okay.
thank you.
But yeah. But when we calculate that time when we discussed last time, we got 0.86. I given same
Yes, sir.
answer over.
Same here, Rajni ma'am. I am also getting this 0.8657.
Yeah.
So
The
maybe at that time I might have crossed this quickly. So that is why this point did not we did not catch this point at that time. But now
Yes.
since we are revisiting the question, so I'm thinking in terms of that because in during the regular session we have to solve quickly 10, 12 problems with the concept. So it might be ignored at that time, but this is how we have to solve. And fortunately, it is fortunate incident for you guys because if this answer is not going to change, then you are going to get marks. And anyway, if they are going to change again, you will be getting marks. It will be for everybody. But that should not have happened. That is my mistake. I am sorry about that. So this is how we will get the flux linkage. Okay. Any final comment before proceeding to the calculation of number of conductors? Okay. So this is how we have calculated flux, right? We know the speed. The speed is given in the machine, that is 600 RPM. So now E by Z, which is 8.567, E by Z is equal to 5. We have got that is 0.433. N is 660. So
4.33. What 4.33?
Acha, I got it now. Why this answer is like that? Because mm, E by Z is given. This we have calculated. That is why we are getting like this. If we have had flux directly here, then flux you could have got 8.567 into 60 divided by 600. So now 10, so it will be 0.85. You got how this answer is coming wrong? Because this information is already provided. We did not need to calculate this flux linkage manually
Okay.
because this EMF per conductor you have calculated, right? That is from the
Mm.
power rating. So from that method, you will get 0.85 Weber. So that's how you might be able to get this answer. If you do not calculate this flux linkage, you will get this value of flux, 0.85, right? You got my point? Because all the values here, out of all the values, E you have calculated, E by Z
Okay.
is, yeah, E by Z you have calculated. The only remaining thing is 5n divided by 60. N is given, 60 is given, only 5 is remaining. So cross calculation you can do and you can find out the value of 5.
So that
Right?
value is 0.8657.
Yeah, that value is 0.8567. Yes.
Hmm. Mhm.
Yes, that value is 0.8567.
Then what 0.433, sir?
0.433
No
if,
need now to calculate.
yeah. So there is some mistake with the data of the problem, right?
Okay.
Like they gave more than enough data that was required.
Okay.
So because if they have already provided the power ratings and armature drops and all, you calculated generated EMF, then again you have all those information. Then why the data for flux linkage they have given, flux density and area and all, right?
Yes. So,
Yes,
sir,
sir.
now how we can calculate the number of conductors?
Yes. So number of conductors. So total induced EMF was how much?
V plus
If
IRA?
V plus
no
IR.
no no. Yeah, yeah, exactly. V plus IRA. This is a generator or motor, DC
Hmm.
machine. So V is equal to V plus nothing is given means you have to assume a generator. V plus IR. V is given 400 volt. I is not given, right? Armature drop is given 5.5 volt, right? So it is equal to 405.
405.5.
405.5.
Yes. So this is total voltage we have got, and voltage per induced EMF per conductor. This is induced EMF. Induced EMF per conductor is
P by Z is
8.567.
hmm,
So number of conductors will be 405.5 divided by 8.567. Should come out to be.
46.
I hope I hope this answer is correct. Is it correct?
Sir, but it is 46, Rajni ma'am. This answer is 46, na?
47.3 it is coming out. It is in the range.
But sir, I have a one doubt.
Yes.
This is a total conductors, yes, sir?
Yes.
Now minimum path are 2. Minimum path, parallel path is minimum required 2.
Okay.
So the
Yes.
question is asked the conductors connected in a series.
Uh-huh.
So it should be divided by 2.
Okay. So first question I'll ask to you. Why the minimum path should be 2?
Because see sir, number of
Huh?
path of flux is minimum 2, na? So
Correct.
parallel
Yeah,
path
you
of
are correct.
windings are minimum 2.
Yeah. So like minimum should be 2. That I got. Yeah. So either for wave winding or lap winding, it should be 2. Yeah, you are correct there.
Hmm.
Now after that, what did you say? Parallel path should be minimum 2. After that,
After the question is asked conductor connected in a series.
yes,
Okay, so we have to divide into one path and the second path, total conductors.
conductors in series. Okay. Hmm. You are correct there. Induced EMF per conductor. Yes. Here they did not ask total conductors.
Yes,
Had
sir.
they
If
asked
they
total
ask the total
conductors,
conductors, then it is correct. But they ask in
yes,
series.
series. Hmm. Yeah. Let us see how this series paths are connected. Okay. Let me present my screen first. So with motor model, we'll be able to see how these paths are connected. Then we will be able to understand it better. But your point is correct.
Mm.
Just let me open this file, this tutorial, EMDC. Yeah, so here I hope you are able to see my screen, right?
Yes, sir.
Yeah. So what happens, how these paths vary. You could see here, this is for phase one, right?
No,
If
sir,
I
I'm
have,
not is getting only your mm, means the another screen is not visible.
oh, is it? Motor card. Is it visible now?
No, sir.
Yeah, it is visible, right?
Rajni,
Motor
madam,
card.
are you getting the screen?
That windings are coming, ma'am. The turns are
Yes, sir.
showing here.
It's visible, sir. Yes, sir.
Motor
JK is
model.
written only.
Path one we can see. Phase one, path one.
Oh, why I'm not
That
able?
that okay. So you
Mm,
refresh your screen, or either you could rejoin. Okay,
okay, I'm
I'll wait.
rejoining.
I'll
Okay, sir.
yeah,
Yes,
I'll
yes,
wait here.
rejoin. Yes. Yes, sir. Now it is
Okay, okay, great. So you could see here, this is the topology, and it is a bit slow because simulation has started. But anyway, you could see all those winding configuration, right? And here, the number of parallel paths we have provided equal to 2. Right? We will see what will happen if we will change it to 1. How the number of conductors will change. So this is the linear path. So in a phase 1, see 1, 2, right? 3, 4, 5, 6, 7, 8. That is corresponding to the one path only. The other path starts from here. So it will divide in terms of two parts. However, number of parallel paths you have assigned, or however number of poles you have given. Right. Now if you make it one,
I think it will not consider. It is done.
sorry, I couldn't get your point.
Sir, how we can assign parallel path one? All are in series?
Yes, so if all are in series, right, then
No.
you can have like this. But this
One parallel path.
facility is yeah, but this facility is not available in DC machine. Why? Because there we
Mhm.
must have minimum one parallel or minimum two
Two
parallel paths.
parallel paths. Yes,
Yes,
yes.
sir. Yes, sir.
Yeah. In AC machines, you could have one parallel path or irrespective of the number of poles. But in DC machines, we have been taught that at least we should have minimum two parallel paths, right?
Hmm.
So of course, the number of turns, if we have two parallel paths, our number of turns per number of conductors connected in series will be definitely half.
Hmm.
Okay.
Yes, sir.
Yes. So your point is correct there. We have to consider that. Let's come back to that slide. Okay, so number of conductors in CDH will be equal to 47.3, which should be equal to 48 because integral number of conductors are expected, right? And it
Hmm.
should be slightly higher than whatever you are getting.
Hmm.
Why? Because at least if you get slightly higher number of conductors, then it might get compensated in terms of losses. So
Yes, sir.
48 divided by number of poles for lap winding. All right, 48 by 2 for wave winding.
Wave.
Thank you for sharing this. Actually, we all ignored this, but
Yes, sir.
that was the yeah. I also just saw the answer and I was feel like yeah, it is coming. But thank you for pointing this out.
And sir, in this assignment 3, definitely maybe my answer is wrong, but for the bore diameter
Mhm.
in assignment 3,
Question number
question number 5, 5, 5.
question number 5.
It is asked for the bore diameter.
Question number 5. Yes, bore diameter.
Hmm.
A
Hmm.
4-pole 225 HP 500 volt, right?
Yes, sir.
Series crane motor as efficiency like that. Pole faces are square and the ratio of polar to pole pitch is that. And please conductors permitted. Yes. Yeah.
Hmm.
So shall we solve it step by step?
No, no, yeah, no, just steps because I'm getting the answer 387.
387. Okay.
Uh,
Okay, but that is not in the range.
yeah, that is not in the range.
Yes. So why might it be? Uh, you applied this expression. Power is
Mm,
equal to d square L into electric loading into magnetic loading. Okay, into RPS. Right? You applied this equation.
sir, again, the same issue. I'm not
It
able to see the screen. Again, I
okay.
have to rejoin it. Mm,
Okay. Maybe your screen layout might be something like that. But anyway, you rejoin again, so it will be default.
yes.
Sir, I'm leaving actually. This is
Okay.
my
Okay.
first time I have to leave.
Oh no problem, no problem. Thanks a lot for joining. All the best.
Thank you, sir. Thank you
Thank,
so much. Sir, it
thank
will
you.
upload now, sir, that
Yeah,
link.
this session will be uploaded.
And
Definitely, it
after
will be
this, we
uploaded.
will discuss this week questions are what I try to get the answers from Google, but the thing is, it's not uh, this week questions, week 12 questions.
Oh,
Rajni, madam, are you getting the same answer? Be different.
1 second, ma'am. Let me check.
Huh.
Uh, may I know what is the question number? Sorry.
Assignment number 3
Assignment 3,
and question
question
number 5.
5. 1 second.
Hmm. Sir, if she is getting the answer, then there is no need because maybe I have to some
Bore diameter 336.26, ma'am. I got that one.
336.
0.26.
Okay. Sir, I have to use this only this formula, na? So I will try
uh,
again. Yeah,
yes,
because
yes. Only this
yeah.
formula, yeah, based on this.
Okay, sir.
Okay. And I think the question we solved during the session that was exactly similar to this.
Yes, sir. Yes. In section we
Uh,
solve na same, sir. So that's why I got
exactly.
336.
Yes,
Yeah.
but at that time I have not referred the videos and I just do it.
Okay.
Actually, P equal to pi square into D square into L into B into A. That is the formula we use it, sir.
Yes.
And L by D ratio also we have. We got
Yeah.
pole arc by pole pitch ratio.
Yeah.
Hmm.
That is given
So
directly.
from the two we got D value.
Yes.
Hmm.
For D value, I don't think any issue should have been there. But
Yes, sir, it
anyway,
is
some
there.
calculation mistake. Just because of calculation mistake, it might be like that.
Yes, sir. Okay,
Yes.
no
Nothing
issues.
else. And here also you could verify that area of flux linkage, that is pi d by p. So
Hmm.
here pi d by
Yes.
p. So again, yeah. Okay, Rajni, you want to leave? You please leave. The session will be
Sir,
uploaded.
yes, yeah. This week questions that in Google we'll get answers, but we didn't get answers in Google, sir. That questions.
Acha. That answers. These are related to FEMM codes, right?
Yes, sir. Yes, sir.
So since the due date is still today, right?
Today night only, sir. I'm checking actually.
Uh, yeah, actually,
Okay,
we are not allowed to discuss it officially before the due date
okay, sir.
because no previous assignments have been provided for this.
Yes, sir.
but I could talk about it a little bit if possible. Okay, like for using 50 depth, right?
Mm. Yes.
Last week we had I have shared a scripting file, right?
Big
Last week
file.
we, we
Yes,
were
yes.
we,
Last
we
week we discussed.
yeah,
With
we were
this
going
week,
through the FEMM codes. Mm, let me open if you're
XTN.
in the chat. Actually, I shared that FEMM file, but anyway, mm, yes, FEMM. Mm, Let me present my screen first. So, yeah, so I hope you are able to see my next screen.
Next screen. Where it is,
Yeah,
sir?
so this is the notepad file
Ah,
I shared, which is actually Lua script, .lua, you could see. And we simulated this FEMM file with bar magnet, right? And we
yes.
explained all these codes here. We define here, like in planar,
Mhm.
see, in planar, we were solving only on the plane. We were not giving any axial direction here because we were trying to see on the 2D. So we were seeing the flux lines of this bar magnet. So I hope that is enough hint here in this line,
EMM
right?
depth from the the T document theta.
So you try changing these parameters, whichever are zero and whichever are not, and then you will get.
Theta. Okay, sir. I have to go.
Okay.
Okay, sir.
Okay. Other questions are like, where is it? 12. Also, we drew certain, rectangle, right? We drew this bar during that session. And this you could see here, all those codes related to draw the bar magnet of this,
Yes, sir.
and how to assign the material and all this with this line of code. We
Okay, sir.
assigned this block, and in block we have a node, and node we had to assign according to the material, what should be the magnetization orientation, like that. Then after this rectangular bar, we created rectangular air so that we could visualize it, isn't it? So AFEM have you installed already?
No, sir.
Raj? Okay. So what you
So
do?
other softwares I'm using, it's not allowed to install. Like total
Oh, it
IT,
is not
right?
allowed.
Not allowed,
Ah,
sir. Admin,
ah.
we are not admins. No.
Yes, in company's system, be able to install, but in your personal laptop you could install because it is very light software.
Yes, sir. Sir, can I leave? Actually, my bus will go now.
Yeah, yeah,
It's a
sure,
final
sure, sure,
call.
sure,
Okay.
sure, sure.
Thank you, sir.
Please. Yeah, thank you very much. All the best. Bye.
Thank you. Chittu, all the best. And Krishna, ma'am, all the best.
Same to you, madam.
Same there.
Chitu,
Thank
can
you.
you share your contact information? Rajini ma'am,
Yes,
already I
ma'am.
have and I have shared my information to
Yes,
you.
yes. I
Yeah,
have your words.
and
Yes,
we'll be
ma'am.
in contact. Yes.
Yeah.
Uh, I,
Okay.
mm,
See you, huh?
Thank you,
Bye
sir.
bye.
okay, okay, bye bye
Yeah,
then.
it was great
Okay.
to have you all. Bye.
Thank you, sir.
Uh,
Bye bye.
sir, I have one question.
Yes, yes.
The answers which we have means confusion about the correction in the assignment. So,
Hmm.
at after what time we can uh, get this correction?
Yeah. So let me write about this also. This was uh,
Assignment number 3,
assignment number 3.
question number 8.
Week 3, question number 8. Week 3, question 8. This one. It is 9 to 11, right? So basically 10,
Yes, sir.
10 and 11.
Yeah, yeah,
Yeah, 10, 10 and 11.
yes.
Mm, Answer should be 0.433. Flux linkage should be 0.433.
Sir, in a 10th, I think there is no confusion because total flux generated.
Yes,
So
yes.
it is already. So in that, no confusion. Only in 11th.
11. But still 10 is wrong, but
Yeah.
the confusion is coming in 11. So,
Yeah. If we will not consider directly given and if we will calculate, then
yeah. Question 11. It should be how much conductor? 848 divided by 2, 24, right?
mm, mm.
If
23 or
840.
24 because of,
Huh.
yeah.
Yeah. Yes, so that I have noted.
Mm.
Any other any other question?
Mm, right now, no, sir.
Okay,
I
great.
think we have discussed these other assignments.
Yes,
Yeah, yeah.
yeah,
And
yes,
the previously we have discussed few more questions in that the answers that will be reflected no, later on, whatever the,
yes,
yeah.
yes.
Okay, sir. Thank you.
Thank you. Chittu, do you have any other question?
Sir,
Yes.
I have a question in assignment 3. Actually, it is not there in assignment, but we have solved in problem solving session, sir.
Okay, which one? Assignment 3. Which question? Question number 2 you are saying or something else?
We solved in problem solving session, but it is not there in assignment.
Okay, which one? Acha, we solved in the problem solving session, but it is not in the current week, like
Yes.
this year's assignment. Okay, let me open that also. And, so could you please hint related to which topic it was?
Uh, it is like Which of the following number of slots is not desired
Acha, like that. MCQ based
for
questions.
player winding, sir?
Okay. Sure. Huh. Yes, I got it. In the design process of an alternator, it is desired that number of poles before three-phase and two-layer winding. Which of the following number of slots is not desirable for the display?
Yes, sir. Could you just
Yeah,
clarify it?
yes, sure. So see, we have number of poles is four, three-phase.
Sir, I'm not able to see the screen.
Acha, oh, I am
There
sharing
is
the other.
assignment screen is there. Yeah.
Yeah, I am sharing other screen. Let me share this. Is something coming up? Any screen is visible or only this grid view is visible?
Sir, I'm not able to see the screen. If you
Okay,
are able to see,
No, sir.
okay. Screen without audio. Let me also rejoin.
madam,
Sir, you are mute.
Am I audible now?
Yes, sir.
Now I am hearing my voice only.
ભૂખ લાગી છે તમને પોવા પડ્યા છે.
Hello, hello. I'm hearing my voice only.
Hello.
Yes, ma'am.
Sir, I think not getting any. There is issue in joining. Hello, sir.
Yeah. Hi.
Yes, sir. Yeah.
I hope I am audible now, right?
Yes, sir. Yes, sir.
Yeah. Thank you. Sorry about that. Sometimes this software is. Huh. Yes. Anyway, let us. Okay, so if you are able to see my screen, the question was number of poles is equal to 4, the number of phases is equal to 3, and which of the slots should be valid, right? So there are uh, four options or something, right? Something like that. It was there.
Yes.
One option was 32 slots. Mm, so why 32 slots are not feasible? You were asking. Okay. So it is better to show you on that again software. This slots of 32. It is 15. So Chitu, are you able to see my the software wala screen?
Yes, sir.
Okay. So here you could see this number of slots I have kept 32. Okay. And it is showing that slot number per phases per parallel paths are not integer. Okay, this number is not integer. And because of it, see why this integer is required, because SPP slot per port is fine 32 by 4, so that is 8, right? Slot per pole is 8 here. Slot per pole is 8 here. Now if you have to divide 8 slots in 3 phases, how will you divide? Are you getting my point?
Yes, sir.
If you have to distribute winding of 3 phase among the 8 slots, how will you equally distribute? That's the issue here. That is why this message you saw now, that slot number I'm writing. I know you are not able to see my this other screen. Slot per pole per phase. Right. It is not integer. That is fine. That is not an issue. There are certain other combinations. They are not integer. Despite that, they are able to be connected. Right. For that, what has to happen? That this should be rational number. So if here 32 by 8 by 3 is not a rational number, right? 8 by 3 is not a rational number, and that is why there is no way
Yes.
to distribute this winding. So for even for fractional winding also, this number should be at least fraction, right? So at least a rational number, so that it should not go like 8.3333 like that. So let's take example of other. What do you recommend? Other slot pool combination that should be fractional without irrational number.
48, sir.
30,
48. It is also
30,
one of the options.
okay, 38. So with 38, let's
48.
28. Sorry, I know
48. 48.
48. Yes, 48 will be integer only. Yeah, 48 if we plug in, then it is a feasible. Yes. Well, I hope you got the point. Like 48 by number of poles were 4, right? Sorry, number of poles we did not assign as 4. Number of poles is equal
Yes, sir.
to
Number of poles is 4.
4. Yes. So for that also winding is feasible with distribution of slot by pole. So 48 by 4 will be 12. So if it is going, it is coming out of the first, let me show you the linear view. If it is coming out from the first coil, then where it should go? It should go after 12 slots. So it should enter into 13. Is it happening here?
Yes, sir.
Yeah. So I hope you are able to see this is entering into 1 and it is going to the 13. So in between the difference is 12, that is slot per 4. And it is a feasible combination. 48 by 4 is 12 and 12 by 3 is 4. So it is perfectly integer. We have uh, fractional like 12 by 10, which is a very, you know, famous combination. 12 by 10 by 3. 12 slots, 10 poles, and 3 phases. Is it rational or irrational?
Irrational, no, sir.
12 by 10, that is 1.2. Okay, divided by 3. What is it? zero point 0.4.
Point 4.
So 0.44 by 10, it is, how is it irrational? It is non-integer, but it is rational,
Oh, okay,
isn't
I
it?
got the point. Yes, sir.
You got the point? Yes. So that is like this. And the throw should be slot per pole. So slot per pole is 12 by 10, 1.2. If the slot by is fraction, then either you can take 1 or 2. Any number is whichever is closer to the integer. You got you got
Yes, sir.
got that point? Which should not be feasible, which will not be possible, which combinations.
Yes, sir.
So that, yeah, that is how we do that. Okay.
Okay, sir.
Any other doubt?
Sir, the FEMM, no, sir.
Yes, FEMM.
How do we learn the coding, sir, for that?
Acha, for coding. So the basic code I have provided, you go through it and see. Uh, there are a lot of videos available on YouTube. Also, you will find. Okay. And nowadays, you know, with the help of these AI based chat GPT and all, you will, any code you will get. If you ask for it, it will provide any. Okay. Even it will explain to you. So just you need to invest some time. And since it is an open source software, it will be pretty easy to learn. Okay. And if you are afraid of coding, which I would recommend don't be, even if you are afraid, there is a, you know, drawing based techniques which you could learn. You could draw all those, like yesterday I drew a rectangle here, right? So instead, by drawing it with the help of code, you could also draw a rectangle directly with the help of line, arcs, curves, like that, you know? So like you place a node here, then again place a node separately at how much distance you want to place. So there are a lot of videos. You take help of those videos. Even in the course lecture also, the coding somewhat it has been explained, but it is not possible to explain entire thing in couple of sessions. But they have tried to explain it. So you will get lot of resources if you are willing to learn the coding. You will get lot of resources, and nowadays there is no lack of resources. You will get everything at your fingertip. Only thing, you just be willing to, you know, invest some time, and you will be able to do it. Okay.
Yes, sir.
Yeah. And there are you are in college, so do your college have any license, other license?
Uh, at present we have for MATLAB, sir.
Okay, MATLAB you have. So yeah, it is very, you know, conveniently coupled with MATLAB. If you go in the YouTube, you will see plenty of videos. Even in the lectures, also the course whichever has been written by the professor, that is only MATLAB code. So you couple FEMM first with MATLAB, and you will be able to simulate it. Okay.
Yes, sir.
So you are in the final year.
No, sir. Pre-final year.
Okay, pre-final year. So there is a lot of time. You could easily learn Excel. So may I know from where, which college?
Uh, Here Chennai, sir. SA Engineering College.
Okay, you are Chennai based. Nice. So there are a lot of automotive companies there. It is a hub for automotive, Chennai. So if you invest, you will get several opportunities there. So learn. You have a lot of time. You just learn this FEA based software and try to get internship if possible. In you are how far by IIT Madras?
It takes about 40 minutes, sir.
40 minutes. So try to get internship there. It will be easy. Okay, you just contact the professor and you say that to see one professor Kamlesh Satwa is there. He is working in the motor design. So you can directly connect with him, right? And you say that you are willing to work in this field because in this field very less people want to work, and I think you'll be able to easily get the internship, and you could complete from there also if you want.
Yes, sir.
Yeah. And no matter what, keep learning. Okay, from online videos, from any interface. That is, or anytime if you need any help, just message me or call me or mail me. Right.
Yes, sir.
Yeah. Okay then. So this was regarding if one topic I wanted to discuss was axial flux machine. You were not able to completely get the full picture, right?
Yes, sir.
Yeah. So this is an axial flux machine. This is the dual rotor single stator. So these are only rotors. This is how a stator will be. This is how rotor will be. So this from this figure, you can see that magnets are attached to the rotor surface, right? Magnet poles are attached to the rotor surface. And since dual rotor, so you can see these are these magnets are placed on the both the rotors, isn't it? Are you
Yes,
able
sir.
to see? Yeah,
Sir.
like this. In the radial flux, they were placed on the radial, right, outer surface. Here it is also they are placed on the outer surface, but axially, right? So that was that. This is the radial view here you can see, and this is the linear view how they will look like. This is a stator, rotor. Two air gaps will be there, okay, and 12 slot 10 pole again. This is a valid combination as I told you, right? 12 slot 10. But winding, how will they be? They will be around the coil. They will be like this, like this. Or rather in 3D, if I try to explain, this is a stator lamination, okay? And in stator, they will be wound like this. Radially, they will be wound. In radial flux, how windings are generally wound? Axially, isn't it? To yeah,
Yes.
let me. Yes, so here the windings will be like that. This is the way of winding along the tooth. No yokes are present. Along the tooth, they will be wounded. And in radial flux, how they used to get wound like this, isn't it? Are you able to visualize the
Yes, sir.
difference in winding? Yeah, great,
Yes, sir.
great. So that is regarding winding, and right. So we can see the back EMF and torque waveform. So first, let us see back EMF waveform. Oh, sorry. I wanted to point out the difference between topologies of this was single stator dual rotor, right? How the dual stator single rotor will look like this something. Okay. So this is how they will look like. Again, the magnets will
Yes,
be on both sides, but on the single rotor, there will be magnets on the both sides of the rotor. And the stator will be supplying MMF from both the sides. Right.
sir.
And yes,
Why do
go
we
ahead.
require uh, such a structure, sir? Is
Why
there
do we?
any special thing for this?
Yes, yes. That I am coming to that point. Why do we require? For that, we'll have to see these flux lines. First, let us see the flux lines for dual rotor, single stator. Then we will be able to appreciate. So you are able to see these flux lines from the permanent magnets and flux lines from the other permanent magnet. They are traveling very less path, right? They are only covering this stator tooth only, right? Where windings are there. So this is the axial length. First of all, are you able to get this geometry construction view? This might be confusing. So this view is nothing but a linear view which could be seen axially, like this view. Mm, this view, okay? So this is the view here. This red one is the stator, yellow one is the winding around them. This green one is the permanent magnet, blue one is the rotor core. Okay?
Rotor. Yes, sir.
Yeah. No confusion here, right?
No confusion, sir.
Yeah. So now corresponding to that only, I'm trying to show you the flux lines. How flux. So if you somehow minimize the flux path, then what you are doing basically, you are saving in terms of material. By utilizing very low material, you are producing same flux because what do we care about? Flux density in air gap. Okay. To maintain the flux density in air gap, if we could maintain with a smaller material, then it is going to be compact machine. It is going to be have high power density, isn't it?
Yes, sir.
Yeah. So how can we reduce those flux path or material? So for that only, this kind of what to say. Yeah, this kind of a structure evolved, and you can see these flux lines. They are just coming from the magnets. They are entering the stator teeth, and they are again coming out from the magnet, right? So they do not have to travel through the stator back arm, right? They do not have to travel through the a longer in radially. They will have to travel all the entire path, whichever comes in the radial direction, from the stator yoke to stator teeth, a stator tooth tip, this air gap, and after that again in rotor path, rotor back arm, everything. And this length is very small correspondingly. So you could see this length is axially this rotor length is 10 mm and a stator length is 35 mm. So in 55 mm, it is able to complete entire path and it is able to produce how much back EMF? That is around 35 volt of sinusoidal. So in that essentially it must be 35 by root 2 if you can do, and you can see how sinusoidal it is. So it is 25 volt. It is able to generate. Okay. Only what drawback is here? It has dual air gap. One thing. So to maintain the same air gap flux density per pole, right? That will be because in a pole there will be two air gap, and both the air gap has to be dense equally. While maintaining that much, you will require more magnets. So here you could say almost, you know, I would not comment in terms of quantity, but it has been almost higher than the radial machine. So that is one drawback. And other drawback would be, note this, let us see the other topology, single stator. Yeah. So this is single stator, single rotor. Fine?
Yes, sir.
Yeah. Now, if we see here, this is the geometry for this single stator, single rotor. So only one stator with winding and only one rotor. Now we have reduced the material further because in dual rotor there were two rotors and permanent magnet is, as we know, it has very high cost. So we have eliminated. But here what the drawback will be, as I mentioned in one of my lectures, that unequal forces, right? This magnet will try to attract this iron core, isn't it? Or this rotor core will be, you know, vibrating, or it will be not balanced at their own position. So we need to maintain this air gap in between uniform, and this air gap must be uniform. But since only one stator and only one rotor is there, this permanent magnet will try to attract this and it will force towards them. Now, if we have a dual rotor, then permanent magnet from other side also they will attract, right? So ideally we keep equal number of magnets, equal amount of magnets, all quantities should be equal so that force should be equal, right? You are getting my point?
Yes, sir.
Yes. So there is no counteracting force here present. That is why unbalancing will be severe. And that is why this model is not recommended generally. And all the industry-based motors, you will see either double rotor single stator or dual rotor single stator. Now, if you build this machine with dual rotor, one important thing is to note here that these yokes are present, right? Which were not present in the dual rotor single stator. Are you able to identify the difference? So that will be more clear. So you can see here, this yoke was not present, right? This magnet flux was crossing this directly to the rotor core. But here now they have to travel in the back iron of a stator. Though there is only one stator and only one rotor, but still, this back iron path is not very effective. If you could make flux transit directly from one point to another without deviating or without crossing the back iron or everything, then basically you are reducing the material. So that is why the earlier version is called as yokeless machine, right? Yokeless stator. So now let us see how much back EMF we have got. So here again back EMF is same, right? Almost, but in where we are losing in terms of balanced forces. Now the other topology is we will state a single rotor. Now this topology has which drawback? From just by seeing this structure, what could you comment here? Simply,
The magnets of the rotor gets attracted, sir.
but they will be attracted towards both the sides. So that force could be balanced. I am not saying that it will be balanced, but it could be balanced, right? But there is one
Yes, sir.
other drawback which I was telling that using this axial flux machine is to save the
And
material.
uh,
Yes,
two
so these,
times.
yeah, so these back irons are present here, right? Which was not
Yes, sir.
present in this case. In this case, back iron is not present. But here, this back iron is the additional component, so which will lead to increment in the motor weight, right? If you go to the here, you can see reduction is almost by 3 kg, 24 to 21 kg. So now let us see. But I guess here back EMF could be higher because we have two stators, so you could incorporate more windings. That is one plus point here. Let us see flux density plot of this model as well. See flux lines of this machine. So is it are you able to visualize that the flux is taking longer path than the double rotor single stator topology?
Yes, sir.
Yeah. And again back EMF is similar, around 35 volt. Yeah.
Yes, sir.
So it is interesting if you want to further analyze, you could do it. Is just to give you head start. Okay, so that's all from my side. Any final question before ending our discourse? It was great to have guys like you, very interactive, very, it is really hard to find interactive students, and it was really nice. Thank you so much for joining every week consistently. Yeah, so that's all from my
Uh,
side. Yeah, please.
yes, sir. Actually, thank you so much for you for clarifying my doubts very patiently.
That's my work and that's my pleasure as well. Thank you. That's
This
so
is
kind
all
of you to say. Yeah.
new for me, actually. We studied everything like theory and seeing it in a practical way is making it more interesting. Thank you for that
Yes.
part also.
Yeah, thank you. That's always there. Once you apply theoretical knowledge into practical, and I always recommend, please do. Many things change. Many things change. So that's there. So I try to incorporate as much as possible in that limited amount of time, along with the theoretical, because theory is equally important. Without theory, if you are getting anything, then it will be like garbage in, garbage out. So theory is equally important, but visualization, I try to make concepts as possible as much to visualize. So that was my effort, and I am always looking for your feedbacks. Please feel free to reach out to me with any comments, any suggestions, any recommendations, anytime. So with that note, uh, I am wishing to end this very interesting course here, and I thank you from bottom of my heart to join all the sessions. To everybody put efforts here. Thank you very much, and all the very best for your exams. I hope you
Thank
will
you, sir.
do very well. Thank you. Thank you. Bye bye. Have a nice
Bye,
time.
sir.
Bye. Bye.
Yes.